So we are in section 6.3, and now I want to look at a couple of examples. You've already listened to the intro, you've already worked through some information through Connect Math and looking at the examples yourself, but now I want to pick back up here at page 340 at example 614. Again, you got to be thinking on the test, how do I recognize what type of problem this is? How do I know what to go grab on my formula sheet? And so looking here, let's look for some keywords. The average drive to work is, and so I would go ahead and actually put it over here. Excuse me, the average drive to work is 9.6 miles. Units are your friend. Help you to stay grounded on what are you looking for, what do you have. Assuming a standard deviation, so whoops, that's going to be sigma. If a random sample of, and start to notice, is this a group of people or an individual? And in this case, it's a group of people, and we get an N, of employed people who drive to work are selected. Find the probability of the mean of the sample miles driven to work is going to be between 9 and 10 miles. So I've already drawn a picture. I think drawing a picture is also your best friend. When I draw my picture, the average is 9.6. It goes dead center. 9 is a little bit below, 10 is a little bit above, and it wants to know what's going to be the probability that all of these people fall in this area between 9 and 10. We have drawn, we have converted, no we haven't converted, but we're going to, and then we're going to find. And sorry you didn't see my underline. We draw, we draw. We're now going to convert. Anytime you have a lower number and an upper number, it's going to cause twice the amount of work. No big deal, just stay organized. And so we're going to have a lower one that is a 9. And that's so funny, they call it Z sub 1 now, and they called it Z sub 2 earlier. Nobody cares. It is the Z at the bottom. And then you're going to have to go grab a formula. Again, up here, were they talking about an individual or a group of people? With the group of people, we have an N, and so we're going to need to go grab the formula that is going to involve finding Z using the central limit theorem formula. That's where we're going to put our N, our group of people. So now back over here, they're literally plugging and chugging. They've got our data value of 9. They've put it in the formula. Minus our mean, 9.6, divided by the standard deviation, and then divided by the square root of the 36. You just got to be really outsmarting your calculator. Maybe use parentheses, maybe use a reciprocal key, whatever you need to do to get the job done. But it says a -2 is popping up. That is our z-score. We just calculated. Stay alert as to where you are. You just calculated a z-score. And when you calculated the z-score, that's not our final number we need, because up here it asked us to find the probability. That means we need to know the area under the curve. And so we're going to need to take that z-score and find out what its area is, actually the probability of that area and the probability of that area. We're going to repeat the process with the 10. Plugged in the 10 minus the mean over the standard deviation divided by the square root of the size, the sample size. We get a 1.33. That's when we run over here, starting with our -2. I'm going to go to my -2 side, and at -2, where's my -2? At -2, -2.0, it says that my area is 0.0228. So I've already written that down. So this area on the bottom side is 0.0228, or about 2.28%. But that means it's everything to the left. To the left. I don't want that. I'm going to want to take that number and subtract it off very soon after I find out what number goes here. So when I look at my 10 number at 1.33, Let me go to my positive side and find 1.33. It's a 0.9082. 0.9082, or about 90.82% of these values are going to lie all the way on the left side of this 10. What I'm looking for is the information in between. So I'm going to go take the probability here of my right side, this 90%, and I'm going to subtract off the 2%. They've already done that for us, and they're finding out that we get 88.54, this number first. If they want a percent, if they want a decimal, we can do both. And so then they start rewriting it and clarifying it in another paragraph. I want you to note, and I like this, that sometimes students have difficulty deciding which Z do I use. So we're now going to practice. Again, looking toward the test, which one would I know how to use? What are some key words? And so notice right up here, this formula should be used when you're talking about a sample mean. A good clue for me is when they have an N. There is an N listed. It's probably going to be what we're going to use, but it's about the sample mean. And this one we're going to use just for individual data, a piece and x, not the mean of all of them, just the x. And so we're now going to work through 6-15. I'm on page 341. And when we work through these, we're going to do A and B. You probably have already guessed. One of them is going to be for individual, and one of them is going to be for the sample. I've also written to myself on the side, draw, convert, find. Draw, convert, find. So starting with the first paragraph, it says the average time spent by construction workers who work on weekends is 7.93. So I'm going to go ahead and even get my drawing started. My average is 7 93/100. And that's over 2 days. Good to know. Assume the distribution is approximately normal. We already knew that, but they have to say it. And has a standard deviation of 0.8 of an hour. So my standard deviation, I'll need that number for later. Part A, we're going to use this top paragraph and answer a Part A question. And then we're going to come back and we're going to use the top paragraph and answer a Part B question. Part A, find the probability. I need a percent. I'm going to eventually end up at that table where I'm going to be looking at these numbers for my percentages. Not sure which way, not sure how, but I need a probability that an individual, the alarms are going off in my brain, boo, 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 and it's telling me if I'm individual, I'm about to use this Z-score, and it cracks me up on this glare. I need to add a light for my document camera to work well, and then it just reminds me of being in class with the glare on the whiteboard. So maybe something's normal. So looking here, I'm going to need to use this Z-score because it's an individual piece of data. Who works at that trade, who works fewer than 8 hours. So I've already put my 8, which is above the mean, and I've got my scribble in because we want fewer. I am elated because that tells me it is what it is. This drawing matches the chart drawing, so whatever number I find, no manipulation needed. It is what it is. I do have this. I do need to do as I have my little part over here, draw, convert, find. I have drawn. I now need to convert. So I'll switch over to their drawing. Here is their drawing. It's individual. I need to convert. So I'm going to take this person had 8 hours, so I'll do 8 minus my mean over my standard deviation. I get about 0.09. I'm going to go ahead and add in, my 0.09. I'm going to go look on my chart. I have 0.09. I'm at .5359. .5359. And this is my area. Here is my final statement for A. Hence, the probability of selecting a construction worker who works less than 8 hours. Remember, less is this drawing, and it is what it is. So whatever I find on the chart, that's my answer, unless I need to convert it to a percentage. The answer to this is, what's going to be the probability that somebody works less than 8 hours? About 54%. That's my probability, or I can leave it as a decimal. I finished part A. I now need to go to part B. Part B says, so if a sample, ding, 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 let the alarms go off again. Boo, 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 boo. If it is a sample, that means I'm going to use Z formula for the central limit theorem, and that's where I'm going to add in my sample size in the denominator. So if a sample size of 40, 40 is going to go right there in my square root, is randomly selected, find the probability that the mean of the sample will be less than 8 hours. Okay, wait a minute. This looks familiar. It's the same question, but now not for an individual, but for the mean of the sample. So if you turn the page, look with me on 342. Again, draw. I like the word convert, and then we'll find. So when we go to draw, it is the same drawing. It's more steep. I'm not going to be grading your drawing and how pretty it is. I just want to see the drawing and the shading, your mu, your sample number, or your means number. I need to see this because I really believe it helps your brain see, I'm looking for the left-hand side, and when I go to my chart, that matches here, so it is what it is. Yay, but I got to go find it. So I've put the numbers up here. 8, that's my mean of the means, the number that we're looking for. Sorry, it's the 8 hours, but it is mu of my means. Minus my my mean. I'm rushing. I need to slow down, just like in class. My mu, divided by standard deviation, divided by the square root of the sample size. Again, be smarter than your calculator. You might want to overuse parentheses. You got to learn your calculator and what it does for you. But when you look down here, I got aboutish 55 hundredths. So I take my 0.55 because I need to draw, convert. 0.55, 0.55, we're sitting at 0.7088. My probability is about 0.7, so it's about 70%. And then it gives us a statement. So hence, the probability of getting a sample mean of less than 8 hours when the sample size is 40 is around 70%. A really cool paragraph here that says, well, wait a minute. When we did the group, it was 70%. When we did the individual over here, it was about 53%. Wow, that's a pretty big difference. One was an individual, one was a group. And then there's this cool paragraph that says, this difference is due to the fact that the distribution of the sample means is much less variable. There's less variance than the distribution of just one data value. The reason is that as the sample size increases, the standard deviation of the, sorry, I've got scribble going on, the standard deviation, the deviation decreases. It gets tighter, it gets closer in to the actual mean. We are done. This is optional. We're not doing it. We're not going to 7.1. That was my note for last semester. We are done with 6.3.